Good morning, everyone. Today we are discussing about the bomb calorimeter. Bomb calorimeter normally used for the measure the calorific value of fuel. So here we have a different types of fuels like solid, liquid, and the gaseous fuels. But the bomb calorimeter normally used for the measurement of the solid fuel calorific value. Okay. So now we are going to discuss about the calorimeter. This bomb calorimeter consists of acoustic steel. If you see, so this is the calorimeter which is having the acoustic steel, in which uh, it gives the considerable resistance for the corrosion and enables it for the withstand with a high pressure. Because when we are finding the calorific value of any fuel inside the any instrument, it will produce the maximum pressure. So that has to be withstand with that particular material which we are using for the measurement of the calorific value. In this calorific value, we have a strong cylinder bomb. This is a cylinder bomb, okay, in which combustion occurs. The bomb has two walls. So these are the two walls. One is to supply the oxygen for the combustion of fuel, which is uh, we are interested, and second one is the release valve, through which after the combustion, whatever the produced gas or the fluid gases which is uh, coming out of the this bomb. Okay, a crucible in which weighted quantity of fuel sample is burned. So about the this is the crucible in which we are putting the measured quantity of fuel which we want to burn it. And here we have the two electrodes which are connected to the fuse wire, and this fuse wire is in touch with the fuel with the cotton, so that once you connect the your connection, the current will pass through this fuse wire, and we can have the ignition inside this crucible uh, with the fuel. To reduce the losses due to the radiation, this bomb calorimeter is having the water jacket which is surrounded by this bomb. So this is the water jacket, and also a stirrer for the keeping the temperature of water uniform, and the thermometer is used to measure the change in temperature of the water, because when we are burning the fuel, it will release the heat. That heat is absorbed by the water surrounded by this bomb calorimeter. So the temperature of this water will get increased. That change in the temperature we are measuring with the help of the thermometer with the accuracy of 0.001 degree Celsius, which is fitted through the lid of the calorimeter. Okay. Now, what is the procedure for this measurement of the calorific value with the bomb calorimeter? Initially, to start with the bomb calorimeter, we are weighing the 1 gram of uh, fuel sample which we are putting in this crucible. Okay, and the fuse wire is stretched between these two electrodes. So here we have the electrodes. This is the connection. Then we are ensured that wire is in close contact with the fuel. Here we are putting the arrow mark shows the fuse wire. So this fuse wire is in close contact with the fuel. Next, what we are doing, we are putting the 2 ml of water inside this crucible, because in the fuel we have the sulfur and the nitrogen, as well as after the combustion also there will be production of sulfur and the nitrogen, which should be get absorbed by the water. So we are putting 2 ml of water inside this crucible, and this bomb, the total bomb is then supplied with the pure oxygen through this oxygen valve at a 25 atmospheric pressure, and this bomb is placed in the weighted quantity of water. So this is the weighted quantity of water in which we are placing this bomb. Okay. Then we have the stirrer. to stir this water so that we can maintain the constant temperature. Even if it is increasing the temperature, we have to maintain the whole water temperature constant. Okay. Then the thermometer which indicates, okay, initially we are measuring the steady temperature, and when the fuel is fired, the heat is releasing from this fuel, so the temperature increases inside the bomb, as well as the heat is absorbing by the water. So the water temperature goes on increasing. So therefore, we have to record the temperature reading every uh, half or a 30-second interval until the maximum temperature is attained. Then the bomb is removed once the combustion completes. Okay. Slowly we are releasing the pressure from this releasing valve to release the exhaust gases. Then the content of bomb are carefully weighted. Whatever the residual which is remaining inside the crucible that we are measuring later. Okay. The heat is released by the fuel due to the combustion, which is absorbed by this water surrounded by this bomb calorimeter. Now, how to calculate this calorific value? Okay, so we are going the next part, that is the calculation. If you go to the next part, if you see here, we are measuring the weight of fuel sample initially, that is 1 gram, then the weight of water, that is the measured water which we are taking for the calorimeter. Then C is the calorific value of the fuel which we wanted to measure it. So that is in terms of kilojoule per kg. Also, we are measuring the water equivalent of calorimeter, because whatever the heat released in the bomb calorimeter, so that will be absorbed by the water as well as the calorimeter, which is made up of the steel. Okay, and this T1 is initial temperature of the water and the calorimeter. After combustion, the temperature changes, so that is the T2, final temperature of water. We are taking the radiation corrections and the specific heat of water as a C. Then we are calculating heat released by the fuel sample, that is weight of the fuel into calorific value of that fuel. So that is the total heat released by the fuel. Then heat received by the water and the calorimeter. So this is the combined of water as well as the calorimeter. So that is the weight of water plus equivalent weight of calorimeter into specific heat of water. Then it is multiplied with the temperature difference. That is final temperature of water minus initial temperature of water plus, so Tc is the radiation correction. Now whatever the heat loss by the fuel is equal to heat gain by the water as well as the calorimeter. That is this Wf into C, equation 4 is equal to equation 5. Wf into C equal to weight of water and the calorific equivalent of water of the calorimeter into specific heat and temperature difference. So through this we can calculate the calorific value, that is C equal to the total weight of water and the equivalent weight of calorimeter into C into temperature difference by the weight of fuel which we have taken for the combustion. Okay, here the value of C we are considering it as a 4.18 as a SI unit. Okay, so this is the procedure of bomb calorimeter through which we are finding the calorific value of a solid fuel. Okay, thank you.